This week on BSD Now, Allan and I are out at MeetBSD, but we never forget our loyal listeners, so we have a great interview Allan did with Scott Long of Netflix and FreeBSD fame, as well as your questions, all on the place to be, SD. BSD Now, episode 167, Playing the Long Game, recorded November 9th, 2016. Hey, I'm your host, Chris Moore.
And I'm Alan Jude.
And that was actually all a lie. It's not November 9th. It may be when you're watching this, but, me and Alan are recording this early. It's the second here. We just finished up last week's episode, but of course, we're both at MeetBSD this week, so we can't leave you hanging with nothing, especially if you couldn't make it out there, which shame on you. You should have come, but hey, I understand. Sometimes you can't get out to these places and whatnot, but it's going to be a lot of fun. And of course, me and Alan will bring you all the details on how it went and give you a recap when we get back next week. But of course, we wanted to present you something while we're gone. So Alan did a pretty cool interview with Scott Long of course, FreeBSD and Netflix fame. Yes. So you're going to want to stick around with that. Where'd you record that again? Was that in UK or Euro?
That was at Euro in Serbia.
Okay, that was one at Euro. Okay.
The Brain Box.
In the Brain Box. Very nice, very nice. Well, that's definitely going to be a good interview. So we'll get that here for you in just a second. Mm-hmm. But of course, we do have a few things we need to do first. So we're going to have to mention our first sponsor this week, of course, which is going to be DigitalOcean. Website for that, DigitalOcean.com. There's no slash at the end of it. Just go to DigitalOcean.com, create an account. And the way you can tell them you heard about it here is when you create that account and you go to your account preferences and enter a coupon code. Enter the coupon code FreeBSDNow. Not BSD Now. FreeBSD Now. And that's going to let them know that you heard about it here over on the BSD Now show and Jupiter Broadcasting in general, which, of course, entering that coupon code does more than that. It gives you a $10 credit. So you kind of want to. I mean, there's no reason not to. I did that here, and that's how I was able to run. I did the lowest NVM for the first couple months, and then I eventually bumped it up to the $10 a month VM because I was going to run some jails, wanted a little more RAM, etc. But anywho, that's a good way for you to go ahead and start playing around with droplets, kind of kicking the tires, so to speak. And once you've decided, hey, I like this, you can upgrade your VM very easily to a higher tier.
Yeah, it's super. You select your image, BSD 11 UFS or FreeBSD 11 ZFS. They have lots of other choices, but you can ignore them. Mm-hmm. Then you choose the size. Do I need, half a gig of RAM, 1 gig of RAM, 2 gigs of RAM, whatever. And then you select a region. What data center do I want to put it in? And then 55 seconds later, you have a VM ready to go. And you can do clusters of them. You can resize them, backups and snapshots.
Attach block storage to them now. I mean, all kinds of neat stuff.
All backed by enterprise SSDs. Their hypervisors are all connected with 40 gigabit Ethernet. It's all good to go. Like I said, they have lots of operating systems, but FreeBSD is the one you want. Don't worry about it.
Yeah. We just make that choice easy for you. Oh, that's good stuff. But yeah, of course, check it out today. And of course, data centers all over the world. So find something close to you, find something far away from you. They have the nice ping testers so you can test your connectivity to that data center, see what kind of bandwidth you can get. But definitely check it out today.
So we're joined by Scott Long from Netflix, and he's back after 3 years since the last time we interviewed you.
Yeah, hi. Glad to be here.
So I guess you can tell us a little bit about what you've been up to the last 3 years.
So I'm still at Netflix, and I think the last time that I talked on this forum, we were struggling to fill up 20 gigabits or maybe 30 gigabits of network pipe. And now we can fill up 100 gigabits. And so I want to talk a little bit about what we did there, and that's really exciting, and what we've also done with SSL, TLS in the process there too. And then there's a bunch of other projects we've been doing at Netflix. I want to talk about those. So
we've been following a little bit of that on the Netflix Tech blog. We were just through some of the stuff in the TLS work recently.
Absolutely, yeah. There was a blog published about a month ago, highlighted the work that Randall and myself and a few other people did, and on SSL, TLS. And so part of the big picture here is that with Netflix, for a refresher for everyone, we deliver video bits over the internet. It's become a very popular thing. And one of the big reasons why we are developing it so aggressively in the kernel is that we need to do it efficiently. We need to do it in a small footprint. So that means that our servers need to be able to fill up 40 gigabit and 100 gigabit pipes. And so to get there, we have done a lot of work: network stack, VM stack, storage stack. When we started this a few years ago, we were using Nginx in its kind of stock configuration, where it would use the send file system call to pull data off the disk and put it in the network stack. We did some significant changes to that allowed it to be fully asynchronous, that allowed us to scale up to tens of thousands of long-lived concurrent connections, and also allowed us to start getting up to filling 30 gigabit data rates. We then found that there were a lot of bottlenecks in the VM system, especially when we were using CPUs that were 16 cores, 20 cores, 30 cores, that kind of stuff. So we did a ton of work there to break some of those bottlenecks. We did that in conjunction with the guys at Isilon, and some of that work has started to get back into FreeBSD. Some of it's still on its way. And those things together got us to a system that we could do 100 gigabit networking, and using Mellanox 100 gig cards at the same time. We did a partnership with them, working on their next generation of drivers. So in all, on a modern Intel E5 system, we can do 100 gigabit networking and still have 45% of our CPU be idle.
Is that a single socket or a dual socket E5?
Single socket E5, E5 2697 V4. Which is awesome, because 4 or 5 years ago when we first started this project, we couldn't even fill a 10 gig port. So in the process of getting to 100 gigabits, we also started thinking about SSL and encrypting all the sessions at the same time. And that led us down the road of looking at OpenCryptor framework, looking at the AES9 instruction set, looking at various hardware encryption offload type of things, and ultimately working with Intel to build a very highly optimized assembly hand-coded library that dropped in as a replacement to the bulk encryption that OpenSSL uses. And anyway, the final result of that is that we can now encrypt at, I think our latest number is 83 gigabits a second on the same platform. The interesting thing is that we actually don't run out CPU cycles at 83 gigs. What we run out of is memory cycles. The memory bus only has a finite amount of bandwidth, and when we're moving the data across multiple times to get from disk to memory to back to CPU to be encrypted, back to memory, then out to the network port, all those transit adds up, and we are out of memory bandwidth. We still have free CPU cycles, so that speaks to just how efficient the libraries are that we're using for bulk encryption. So that's been really super exciting. The library that we use from Intel is called ISAL. It's open source. It's available on their GitHub and io.org or 01.org website, and we're turning it into a port into FreeBSD, and all the glue that we have in the kernel to wire it into our send file system called Path is going to be open source as well.
Cool.
So yeah, super exciting there. We're looking towards like 200 gigabit and 400 gigabit networking. The keynote for EuroBSD this morning, George talked about, in 10 years we'll be doing terabit networking, and yeah, we're already looking in that direction, looking what it take to get FreeBSD to do that.
Yeah, so that is, by the time the hardware is available, you don't have a lot of time for the software to catch up.
Right. So yeah, exciting times with networking. So we, while we were working on that, we started looking at what does it take to get more vendors involved in FreeBSD. Networking has been a traditionally kind of up and down roller coaster in FreeBSD. Some vendors have been fantastic. Some vendors have been, lagging behind, a lot of hand holding. So we started working with some people in the community and funding them to work on a new thing called IFLib, which is basically a layer on top of the IFNet layer in the FreeBSD networking stack. And what that means is it's basically a new library for writing device drivers that takes a lot of the copy and paste that device drivers typically have, that network drivers typically have.
And just a lot of the FreeBSD specific bits out of the driver?
There's still a lot of FreeBSD isms in there. There's still mbuffs. It's not like you can just take a Linux driver and pop it in and have iflib remove all those abstractions. But it's taken away a lot of the difficult stuff. Handling iactls, that's traditionally been difficult. This abstracts away that, and high performance multi-queue lockless processing of packets. This abstracts that too, and that's traditionally been a very hard thing to get right in FreeBSD, and that's one of the reasons why some drivers have been higher quality than others.
Right, and a new driver, if they pick the wrong driver to copy and paste from, then they end up not being as good as it could have been.
Exactly.
So having one, this is how it's, a lot of the plumbing's done for you, so you don't do it wrong.
Exactly. So hopefully it results in vendors being able to write higher quality, higher performing drivers for less engineering overhead. So we'll be able to get more vendors engaged in doing this. We can sell it to them as you don't need to hire an army of super awesome elite hackers to write your driver. Your existing staff of engineers can do it using iflib and get great results. So initial cut of that went into FreeBSD 11, and we're coming back around now and looking at what it takes to finish that up and get some of the major drivers in. There's variants right now for the Intel drivers, for the Broadcom drivers, and we're talking about Chelsea and Mellanox as well. So that's all going into FreeBSD 11. If it doesn't it's too late for 11.0 for a lot of this stuff now, but we're going to look at what it takes to get into 11.1 and then obviously into FreeBSD 12.
Yeah. That's good stuff.
So like I said, it's kind of boring on the technical side, but it really is meant to get more vendor engagement in FreeBSD, which helps FreeBSD in the long run.
Yeah, that's something that traditionally been relatively hard to do, is actually get vendors to care about open source, or even once they do, specifically FreeBSD.
Right, yeah. Vendors say, there's a big market for Linux and there's a small market for FreeBSD. We just can't afford to hire someone to work on just FreeBSD. And what we're trying to say is,
we'll do what we can to make it as easy as it is possible for you to just not have to spend a lot of time to be able to support us.
Right, exactly. And then related to that is graphics drivers. Mm-hmm. And so we've actually been funding a lot of work in the graphics driver stack for FreeBSD. And you might say, well, why does Netflix care? We don't run a GUI on our OCA servers. And really, this has been kind of a moonshot thing for us. Kind of let's see what we can do to help the community, even if it doesn't help us directly. And the point there is that graphics on the desktop has fallen way behind in FreeBSD, and if you look at any BSD conference, you'll see that majority of the audience is running a MacBook
or a really old Lenovo. There's 2 or 3 laptops that could still be used, and they're at this point they're 4 or 5 years old and getting harder and harder to buy.
Right, exactly. So we want people to dog food FreeBSD, and we want people to be able to jump into FreeBSD and evaluate it without being stopped by the fact that they just came and get a desktop going.
Right, because that's important to having the next generation of developers, or just expanding the developer base, which in the end helps benefit Netflix.
Exactly. This is an investment in the community so that the community stays healthy and benefits us and everyone else in the long term. So there have been projects throughout the years to try and port graphics drivers to FreeBSD, to try and re-implement graphics drivers in FreeBSD. A few years ago, the FreeBSD Foundation supported an effort to re-implement a certain level of graphics driver support into FreeBSD using native interfaces. It was successful, but in a limited sense. It kind of brought things up to work for a few chips, a few laptops, but there was really no path forward, and it was a huge amount of development effort to get that far. Mm-hmm. So what we looked at was that Intel being the major player out there, the majority of the laptops out there, I mean, Intel shipping them, and Intel has these Linux drivers that they have a whole army of people working on. We can't possibly try and fund a parallel effort that's native FreeBSD, but what we can do is we can leverage the Linux code and write shims in the kernel that would allow us to just recompile the Linux code into FreeBSD kernel, thunk the various system or the various APIs. And in the end, maybe it seems a little ugly. It seems like we're going through an extra layer, but it gives us drivers now that work.
And ideally will mean that the next driver will slot in much more easily.
Exactly. So Linux graphics works on this kind of version number that's paired to their kernel version. And for a while, FreeBSD was stuck on what they called DRM 4 of I think 3.8 or 3.9.
That's 3.2.
Maybe it's even older than that. 3.x, really old.
Yeah.
And
basically up to Ivy Bridge, and that's quite a few generations behind nowadays.
Right. That's really old Linux kernel interfaces and really old hardware support. And there have been some efforts going into what it would take to step through and go 3.7, 3.8, 3.9, 4, 1, 2, 3, 4, all that kind of stuff. And instead what we did is at the time, DRM 4.6 was the latest branch to develop on. So we just targeted that and leapfrogged everything to get to DRM 4.6. Got that done, then that supported everything from Skylake back. With a few minor exceptions, there were some problems with some really old graphics cards that used HEP hardware and APIs, and I think that might have gotten fixed. I'm not exactly sure. I need to go back and check. Anyway, so we got that done and it worked. And then when DRM 4.7 came along, it was actually a minimal amount of effort to adapt what we had to that.
Right, because the diff was so much less this time, it was easier to just import their changes.
Right. And what we're doing still requires some changes to the Linux sources. The ultimate goal is to have the shim layer be so complete that the Linux sources require no changes. Right. That's going to be a difficult goal because as the technology advances in graphics, they're adding new interfaces into the Linux kernel that the drivers need to use. So there's always going to be work to do in the Linux KPI layer in FreeBSD to keep up with that. But we think that's going to be easier to follow that than it's going to be to try and constantly change the code, constantly re-implement things from scratch. So I think it's up to, I think the work right now is up to DRM 4.7. 4.8 is already in progress in the Linux world. We're looking at what it's going to take to fund that. But the good news is that we support graphics now that aren't even released. Yeah, so the next generation Kaby Lake that was just announced at IDF a couple weeks ago, we already had a prototype test system from Intel, and our drivers already work on that. Mm-hmm. So instead of being years behind now, we're actually ahead. And in some ways, we're even ahead of Linux, even though you could download a Linux kernel tree that had this, latest and greatest DRM drivers. If you went and downloaded Ubuntu or CentOS or something like that, you're typically many generations behind already anyway. Mm-hmm. So we're actually in some ways even ahead of Linux in that respect. So really cool there. There are wiki pages that are easy to find on Google that talk about how to bring the code into FreeBSD and get started with it. It's a relatively straightforward process at this point. Mm-hmm. And for FreeBSD 12, we're going to look at getting all that code directly integrated in so that you can build from ports just like you would build the rest of the X server. Yeah,
and the advantage to that is it means that when there's an update for it, it's available in whatever release you're on immediately instead of in the next FreeBSD release. That's who knows.
Right, could be years away, right?
Yeah.
So I guess that's an important part is that we're also looking at kind of decoupling the graphics drivers from the FreeBSD base source and putting them into ports. So like Allan said, you don't have to wait years for the next stable release of FreeBSD in order to get a new version of the drivers in order to support your new laptop.
I think that'll help the situation quite a bit.
Yeah.
Because, and maybe the new release model will also allow us maybe to move forward a little more quickly, but I think the packaged version of the driver will just solve the problem very nicely.
Yep. One interesting thing is that Intel is really focused on Wayland, not X11. So since Intel is also really the biggest driving force in the graphics world in Linux these days, that's going to make things very interesting for the next few years as they push all of X11 or all of Linux and by extension FreeBSD away from X11 and towards Wayland. So the DRM drivers work for both. I know there's work going on in FreeBSD world to support Wayland. So that'll be something to keep an eye on for the next couple of years is that transition and the drivers staying up with that transition.
Yeah. I think it'll definitely be interesting to watch how that evolves.
So that's what we're doing at Netflix. On the FreeBSD side of things, let me think if there's anything else. Oh, we're reinventing TCP. It's a trivial thing. We did that last weekend on a plane ride. No, so one of the things that we're trying to combat is packet loss and high cost of retransmits in the network stack, and that makes a lot of difference when you're going into parts of the world that have poor connectivity. When you're trying to get to sub-Saharan Africa or India. Those kind of places where networks are there, but there's high loss, and you want to maximize them. So we've looked at things like Quick from Google. We've looked at a bunch of different academic proposals, and what we're working on is something called RAC, that basically re-implements congestion control and retransmit logic in TCP. It's still TCP compliant. It still works through all of your normal routing and firewall infrastructure, unlike some of these other more exotic proposals do, but it's a major change to how we treat packets and how we treat loss. A big part of that is packet pacing.
Right.
What we found is that for our workload, a client would request a chunk of video, and we'd send it out to them. We would send it out in such a quick burst that along the way it would hit a router or switch that wasn't well buffered.
Right.
And we get tail loss. We get some of the packets drop off of that, which then would cause retransmit.
Yeah, because streaming video is kind of a unique case where there's a relatively constant bit rate that the user is going to be consuming the video at, and you just want to be above that. But if you go too high, then you might actually reduce the quality or just take up your capacity that you could be using to make sure you're not starving another user. Right,
and the thing is that even though we're streaming, it's all very bursty on the network because we'll buffer a minute ahead,
read ahead,
but then we're not constantly sipping. We're requesting chunks every 2 or 4 seconds. So it's that burstiness that can cause problems on intermediate networks. So we're working on RAC to try and mitigate that. We're working on packet pacing. We have an implementation right now that we're testing, about to deploy, that will implement software packet pacing, and we're also working with hardware vendors to implement hardware packet pacing. So that's going to be really kind of one of those key things that makes 100 gigabit networking and beyond work, is realizing that if you pace the packets out, if you put gaps in between your individual packets and allow other packets to fill those gaps that go to different places, that you're not going to overload your switches along the way.
Right. And this kind of works almost the opposite of your regular TCP segmentation offloading, where you're trying to batch it all together and send it to Nick at once. Because I've done that, Nick, now, but I want you to hold on to it a little bit and intermingle the flows.
Right, and that's going to be one of our challenges for performance, is that if we have to do software packet pacing, then we basically can't use TSO, or it's not going to be nearly as effective.
Right.
TSO gives us a 40x improvement in, instead of sending 40 packets down, we send one big packet down. 40 packets that are 1,500 bytes, we send one packet down that's 64K, and we lose a lot of that with software packet pacing. So, like I said, we have 100 gigabit length. We're only using 45% of the CPU. Well, when we try and rack, that savings goes away because we're now doing a whole lot more transitions up and down the network stack to get the same number of packets out. So work's going to continue on with that to make software packet pacing more efficient. And like I said, if we can do hardware packet pacing, then we can still basically do TSO and have the network card
deal with some of that.
deal with interleaving and pacing things out for us.
And then you need some kind of control interface to instruct the NIC about how you want to do that, right?
Right. So there's proposals there about how we, what fields we add to MBUFs to make that happen. Mm-hmm. And there's been some fabricator reviews on that for the last few months that Mellanox and Chelsea have been participating in.
Yeah, well, it'd be good to have the tools for controlling the pacing be more generic rather than specific to each driver. You get a vendor tool to configure the NIC or whatever.
Exactly. So then the last thing is that when I last was on here, we were transitioning from stable -9 to current -10, mm-hmm. and we were big advocates of tracking as close to head as we possibly could, so that all the work that we did could be quickly pushed back into FreeBSD. All the new things that are going into FreeBSD could be pulled into our tree, and we get this nice back and forth feedback loop of code reviews and technology and all that kind of stuff. We kind of got sidetracked for a little bit and wound up on stable 10 for a lot longer than we thought we would. So we made a decision a few months ago to just leave Prolog 11 entirely and go straight to 12 current. And within the next 2 months, by the end of the year, calendar year, at the absolute latest, our entire network of FreeBSD servers is going to be running 12 current.
That'll be good, and then hopefully that'll make it easier to get stuff that Netflix develops upstream more quickly, right?
Right, exactly.
And also, it sounds like quite a bit of the Netflix stuff is kind of developed in collaboration with, Isilon or a driver manufacturer and so on. So having everybody able to just work that head makes that so much easier.
Exactly, and hopefully it provides an example for others that head isn't as scary as it used to be. Mm-hmm. That it really is worth the little bit of extra risk and bumps in the road, and things not compiling every once in a while.
Yeah, and I think once we get the package-based stuff sorted out, so it's easier to in production actually run as something like 12 stable or 11 stable, mm-hmm. even, and just being able to update to weekly snapshots of head rather than having to build it yourself all the time.
Right, exactly.
Or build your own deployment system to push out binary updates or whatever.
Exactly. So yeah, really excited there. We're also putting some tooling so we can actually track the how things are going with 12 current, and how often does the build actually break, and how often do we actually get regressions, and what are those regressions? Maybe it's performance regression, maybe it's functionality regression. So we're building some tooling that we hope to share the results with the community here in the next few months.
Yeah, that'd be good too. And I guess you've been doing quite a bit of storage stuff as well, right?
So we are shifting over from being a hard drive based platform to being NVMe based, and we predict in a couple of years we will never buy a hard drive again for our platform. That's all going to be SSDs and NVMe. So
are you able to get the same density? Like, you can't fit 36 NVMEs into a machine, right?
Not yet, but when you start talking about high capacity, low endurance flash,
right,
where it's 1 drive write per month or 0.3 drive writes per month.
I guess your workload is different than trying to run a database off of an NVMe, right?
Exactly. Once our drives get full, they have very low churn rates. 1 to 3% per day at most. Mm-hmm. So doing like 1 drive write per month makes a lot of sense for us. And when we start talking about those flash densities, people have already announced 100 terabyte NVMe drives with that kind of endurance on them.
But yeah, I guess most of the ones I've seen are single digit terabytes is the biggest you can get, but
right,
that's
2 or
much
4
higher. That's like 300 or 900 drive writes a year kind of thing,
right? Versus
0.3 per day.
Right, exactly. So yeah, looking forward, it's going to be flash. We think the price is going to come down to be lower than SSDs in the long term, mm-hmm. competitive with where hard drives are. And
well, especially for your workload that's so multi-threaded, right? You got like 10,000 concurrent requests going on in a box.
right,
And
close to 100,000 actually
yeah.
when you talk about 100 gig interface.
Well, yeah, it's a 100 gig interface. NVMEs that are executing hundreds of concurrent IOPS rather than one at a time.
Right. So, our Spain drives could only do 50, 60, maybe 80 IOPS because there's just so much head movement going on. Even though we're streaming movies, when you have several hundred streams coming off of each individual drive, that requires a lot of head movements.
Right, and you're not reading 4K sectors. You're trying to read like 1 megabyte chunks.
Right. So, yeah, our IOP rate off the Spain drives is very low. When you go to SSDs and NVMe, suddenly, head movement doesn't matter anymore. It can be a very randomized workload, and you get almost the same performance. So we can get, hundreds, if not thousands of IOPS. So, yeah, that really simplifies our IO stack and all the work we have to put into IO scheduling. And it allows us to build a much more dense box too, because we can put in a few drives that are, maybe 10 or 20 or 50 terabytes, and have the same capacity in 1 or 2 U's that we had before in a 4U,
yeah.
right?
And probably uses less power as well, right?
Yeah, exactly.
And when it's in your data center, you have some flexibility there. But when you're getting other people to host the boxes in their own network, often they're very sensitive to that.
Exactly. Like I said, it's footprint. It's number of U's, but it's also power. So, if we can take what was a 4U 500 watt box and turn it into a 1U 200 watt box, everyone's happy.
Yeah. That should be quite interesting. Do NVMEs have the same level of the need for your IO scheduler that SSDs did?
Yeah. In fact,
to avoid writes to avoid slowing down the reads?
Yeah, it's all the same problems there. That our original model for IO access was that we would serve just reads out of the box for 20 hours a day, and then we switch over to what we call fill mode, where we would churn the data, we would bring in new movies, new content, that kind of stuff for 3 or 4 hours a day. So it was all reads, then it was all writes for a short period of time, then being back to all reads. For a lot of our networks now, we have to do trickle fill, which means that we're serving for the entire 24 hours and also doing some writes in the background the entire time.
But throttled to a rate that it doesn't affect the performance of your reads.
Right. Correct. So, doing mixed reads and writes on flash really destroys your performance very quickly. Warner Wash did a ton of work on writing an IO scheduler that could prioritize reads and writes and without penalizing either one excessively. We put that into CAM, and now we're working on bringing the NVMe driver into CAM as well, so they can make use of that. You might say, why do we put it into CAM and not elsewhere? What we found was that we can build a very reactive scheduler if we have access to all the stats that CAM keeps in terms of the exact time that an IO is out on a drive and the both the software and the hardware queue depths that are in play there for the commands going out.
And it just gives you the information you need to make the decisions.
Exactly. People done IO schedulers up in Geom to various levels of success, but what we found was that we really needed this feedback loop on what was going on in the drives. If we were going to do it in Geom, we'd have to pump all that information up to Geom. Well, it's already in CAM, so why don't we put it in there? One of the advantages also of having everything in CAM is that if Intel starts supporting SPDK for FreeBSD, which is kind of the storage equivalent of DPTK, where you have direct access libraries in user land to storage, they can do it through CAM instead of having to modify every driver directly. So I'm actually going to talk with Intel about that next week. But bringing SPDK to FreeBSD and doing it with CAM so that kind of unifies the interface for them.
Yeah.
Okay, back from the interview. Hope you guys enjoyed that. Scott's always fun to talk to, and you can meet people like Scott if you come out to these conferences. I don't know if he's going to be at MeetBSD with us next week, Allan, but he definitely comes out to he came out to Tokyo last year, and he's usually a regular at BSD Can and whatnot. So, and of course he was at Euro where you did the interview. So Yeah, Scott gets around, so you can meet cool people like that. Come out to the conferences, and it'll be a lot of fun. In addition to meeting, of course, me and Allan as well. Anyway, we got to mention our next sponsor here before we get into your feedback and questions. So next sponsor this week, of course, is going to be IX Systems. Website for that, ixsystems.com/BSDNow. You can go there right now, fill out the handy-dandy little form, and one of the sales engineers get in touch with you and see what they can build you today. Of course, they can build you stuff based around the latest and greatest Intel processors, or maybe you need a little older one, something that harder to find. Well, they're going to do their best to track that down for you. I know Allan needed a specific chipset at one point to do transcoding.
The nice thing is now our new build doesn't require that. So we got the latest and greatest Intel processor at the price point we wanted. It actually has 10 cores plus hyper-threading. I remember paying that same amount of money for one with only 6 cores not very long ago. So
it's just good stuff. And of course, IX Systems, they're going to treat you right, give you the white glove treatment the whole way through, and make sure you get taken care of. So couple tips though. We try and, you guys are pro users, obviously. If you listen to BSDNow, you're expert level. So first up, when you call them, tell them you heard about it here, because they're going to be like, oh, these are BSDNow listeners. These guys know what they're doing. Second of all, to be very specific. Tell them exactly what you want to build or what you're trying to do, so that they can help make intelligent suggestions like, oh, this is the kind of disks you want to use, or, oh, don't waste money on a ZIL, spend it instead on a larger L2 ARC, or maybe you're not doing ZFS at all. Heck, they do servers for pretty much everything. So they'll help you figure out how you can wire it and configure it and do everything to get the best possible performance. So be as technical as possible. They need that information to build you the right system. So they're happy with how happy you are then. So definitely get in touch with them today. And of course, tell them you heard about it here. They love hearing from our listeners. Okay, our first question this week comes from Zach. He says, Allan and Kris, I'm relatively new to the show and I love it. I have a question about USB config. I'm not sure if you guys can point me in the right direction. Well, I hope so. Maybe it will help anyway. He said, I've got a Lenovo Yoga 2 that I finally got FreeBSD 10.3 installed on. He says TrueOS wasn't happy with something that might be related to this. He said, anyway, it looks like I have to enter USB config -D, and then he has to set power off on a few different devices to suppress some power cord and touchscreen issues. Is there a way to pass that in on boot or some init script startup? So I'll answer that first. Yes.
Yeah, there's ways to do that, although it'd be interesting to know what those two devices are and what issues they were causing you. But anyway.
Yeah. But I throw things like that in rc.conf personally, or rc.local.
Yes, rc.local in etc is probably the best place to put little things like that.
Yep. He said the other thing that doesn't work is the built-in Wi-Fi. He said, but I might use an EddieMax USB device or wait and see if BSD 11 or newer version of TrueOS fixes this. Yeah, definitely try the newer TrueOS. That may actually have the newer Intel IWM drive.
Probably fixes every Lenovo.
That's right. And he said, also, I've been using Linux for years, since 1998 in the server room here at work, and now we're slowly migrating it to FreeBSD. Nice. Well, that's awesome. We'd love to hear that. So he says, thanks for the great shows and keep up the good work. And that's Zach. Well, thank you. Well, again, I would be curious to know also if you try a newer TrueOS, or if you have since you sent us this email, let us know if that works or not. If you're still having issues, I want specifics on that so we can take a look at it and fix it for you. Okay, so next up is Jens, who writes in and says, Hi, Allan, it's me again, the guy with the weird question. As the Redmonian Evil Corp is now propagating sandboxing to their e-browser, I had to ask myself and Rakai and IRC, what is the difference between virtualization, jails, and containers? Thank you for your time.
So yes, virtualization is when you create a virtual computer on your computer to run some other operating system, basically. Containers is basically when you create a boxed off area on your OS that has applications in it. And jails are kind of a hybrid of the two. With a jail, basically you have an entire second copy of FreeBSD running in the container, but it shares the kernel with the host system, whereas in virtualization you would run the whole operating system.
So separate world and like your user lib and all that stuff is separate. But again, so less memory than a full VM solution, but sharing the kernel.
And the other big thing is that you share all the resources, right? If you create a virtual machine, you give it 2 or 4 gigs of your RAM, it has all of that, and any RAM it wasn't using doesn't necessarily become available for use by the rest of the system. With jails, you're basically sharing all the applications, everything with the host system. So with jails, when you run top on the host, you see all the processes running on the host and all the processes running in all the jails. They just look like normal, except for, in top, they'll have a different JID, or in PS, they'll just have a letter J to let you know that those are running in a jail rather than in the host.
I think it's funny. He didn't even ask about sandboxing, though, which that would be technically different, I think, in web browsers. Yeah, so I don't know how Microsoft's doing it, but so sandboxing in Chrome, for example, they did some messing around with that with, why am I drawing a blank on the name now? The stuff they did at Cambridge.
Capsicum.
Capsicum. Sorry about that. Capsicum. But, there's different methods to accomplish that where you're sandboxing a particular area of an application, but it's not necessarily that the whole app's running in a container, if that makes sense.
Yeah. Sandboxing is more inside an application, separating parts of the application from each other, usually. And so that, you sandbox a tab so that tab can't look at what your other tabs are doing. Although Capsicum and Chromium are attempting to take that even further, so that while loading
sandbox an image in the tab.
Like if you're looking at your Gmail and there's an image and it's the bit of Chrome that processes that image and displays it for you, if, like Apple had the other week, there's a flaw that allows a JPEG to execute remote code on your machine, it doesn't have access to read the email that it was embedded in and things like that.
Yeah, so definitely good stuff. Okay, well, hopefully that helped answer your question there. Let's see here. So next up is Ranco. He mentions, hey, guys, I heard on episode 161 that someone had to type his key to recover. And he's talking about TarSnap. He said, I have a much better solution for that. When printing it out, dump the text to your Office suite of choice, change the font to be a clear, bold, fixed width fonts, reduce the margin to the smallest your printer will allow, and bump the text size up to fill the page. He said it can take a bit of fiddling, but the advantage is that it's now OCR compatible. Slap that piece of paper into a scanner and you're done. If I've tested this, and even low-quality OCR software will usually be accurate if you can get the text above 12 points. I actually did that with my key. So I printed it as big a font as I could, biggest size, and then laminated it just to be on the safe side because I didn't want the paper falling apart. But anyway,
yes, know,
that's definitely a good solution.
Brooks Davis, who we've interviewed before, actually was thanking Colin last time the three of us were together, I think it was in Cambridge, for the fact that in a TarSnap key, the very last character in each line of the key is a checksum. So that if you're typing out that giant key to recover it and you mess up, it can tell you, oh, you messed up on line 7. So that you're not like, oh, I typed this entire thing and maybe I've typed one of the characters wrong. It's like, no, it's line 7 that's screwed up. It's like, okay, fix it.
Yeah. That is definitely helpful.
I've also heard of people turning it into a QR code type thing so that you could just read it on your phone or whatever.
Can you get that many characters in a QR code?
I don't know.
I didn't think there.
Maybe it was a series of QR codes.
The limit.
I don't know. I think if you make it bigger, eventually you can get anything into it, right? I don't know.
A massive old QR code. Awesome. Okay. Well, let's see here. So next up we have Alex, who asks, he says, I don't know if it made any release info, but as of OpenBSD 6.0, it runs in Hyper-V now. I don't know if we mentioned that or not before. I think maybe we did at one point, but maybe before the release. Anyway, he said he's tested with Legacy Network Card, not the newer one, but I can now put an OpenBSD PF firewall between my VM network and the rest of the network for testing. Interesting. Okay. Well, thanks for bringing that to our attention. He also says, thanks once again for all the excellent work. I'm in the process of trying to mold FreeBSD and TrueOS into a package deal for small businesses. Once I get further along, if you're vastly short on interviews, I'll be happy to come on and talk about it.
Awesome.
Yes.
We'd love
to hear about what you're doing. That would be good stuff. So anyway, keep in touch. Email us when you get a little farther down the road and want to talk about it. And then last up, we have kind of a funny one here, but Kurt Dox, who we've talked to many times on the show, he sent us a bunch of stuff and helped out with the PCBSD project, of course. He has an idea for a discussion segment. He said, how about out behind the bike shed or just behind the bike shed? The first, if you consider bad boys are always taken out behind the woodshed for their whooping because they did something wrong, it has an ominous ring to it. But all those who know what bike shed is refers to that bike shed refers to coder or tech oriented as well. So yeah, it's kind of good. That plays on both. Maybe we should do that. We should have like a semi-recurring segment or whatever called Behind the Bike Shed or something. Taking you out behind the bike shed. I like it.
Probably better than our Star Trek versus Star Wars one.
Yes, please. Anyway, well, we appreciate it, Kurt. We'll see if we can get that worked into a future episode. That'll be fun. Okay, so we're going to close out the show here for this week, folks. And of course, before we do, we want to mention our last sponsor, which is going to be TarSnap. So the website for that, we just talked about it here in the feedback section, but TarSnap gives you those pretty keys. But anyway, the website, tarsnap.com/BSDNow, where you want to go there, get signed up, make your account, grab a client, download the source code, compile it yourself, do whatever you got to do. Just make sure when you do get that key, you print it out, make a hard copy of it somewhere.
Maybe in a bigger font, like we were just mentioning.
A bigger font that you can read with some OCR reader down the road. So if you need to recover, you can do that without typing that in. So definitely good stuff. But of course, TarSnap, me and Allan are both using it here. It sounds like a lot of our listeners are starting to catch wind that this is really the right way to do backups. So we're really glad about that. And we're glad to hear you guys are using it and having such good luck and success with it. So keep on TarSnapping away. And if you haven't tried it yet, you're really, not doing yourself any favors. Yep. You should try it out. Do your backups the right way. Do it the proper way. And you don't have to trust the remote end, which is the best part. Trust nobody, right? In this world of computing, and you just watch the news and hear about stuff getting stolen all the time, and backups and things in the cloud, and who knows what, right? You want to use something like TarSnap. Maybe we shouldn't be telling this out, like all the leaks and stuff that have happened. Now everyone's going to know this is what I should be doing to back up my data. But anyway, TarSnap's what you want to do. So for those in the know, they choose TarSnap.
Yes, it's the slogan: backups for the truly paranoid.
That's right. Definitely for the truly paranoid, of which I think I would count myself maybe mostly among that. Maybe not as paranoid as some, but more paranoid than others for sure. Okay, so of course, as we wrap up the show, we'll be back with a regular episode next week. I think I fly home Sunday night, I think.
Sunday
the show ends.
Here, so.
So, okay, yeah, I think same time for me. So we'll be back with a live show next week, of course, and be able to tell you how MeetBSD went. Hopefully it was a lot of fun. Looking forward to it. Now I actually just got to go finish writing my slides and get my talk ready.
I managed to get mine turned into a panel, so I didn't have to do that.
You don't have any slides. Yeah, lucky you. Anyway, I got slides to do, so I'll be doing that in the next couple days. But anyway, as we wrap up, of course, want to remind you, feedback@bsdnow.tv is where you want to send all your info in. So if you have questions, comments, if you have show ideas or topics, anything you want to bring to our attention.
If you want to volunteer to be interviewed or volunteer someone else.
Yes, that is true. And hopefully we get a bunch of interviews while we're at MeetBSD. Just a warning to anybody attending, you could be subject to an interview. So a microphone will be thrust into your face and we will tie you down and force you to give us an interview. Probably not, but we'll be nice about it. But seriously, we want the interviews. So be warned. So anyway, we will see some of you next week at MeetBSD, of course, and the rest of you will see live next week. So have a good one.